Hello everyone, so we are back at it again. Today we are doing our paper review for AdMaths. This set is from February-March 2021 and it's set 12 here. So make sure you are looking at the right paper. So without further ado, let's get started with our first question here. Okay, this one is actually quite straightforward. What we are dealing here with is actually something like a quadratic, because I noticed that there was a square there. So that's the first thing that I came up with, and so I will get rid of the learn 5x there first, because some of you might find it confusing. You can always set it as something else. So in my case, I will set it as z. So 3z squared plus 2z minus 1 equals to 0. Okay, so from here onwards, you're using your quadratic. So you actually get two results here. So I'm showing you using my calculator, but it looks slightly different from what you're using actually. So just key in accordingly. The A will be 3, B will be positive 2, while your C is negative 1. So by keying this, you get your results as Z equals to negative 1, as well as Z equals to 1 over 3. So you actually have to work it backwards from the results. So just key in Z plus 1, because I'm shifting this thing to here basically. So for the other one, the brackets over there, it will be 3Z minus 1 instead. So with these two results, okay, remember you're not looking for Z here. You still have to fulfill the requirement by identifying what's your x value. So the Z there is basically your learn 5x equals to negative 1, then 5x equals to 1 over 3. So when you solve it accordingly, for those who is unsure or unfamiliar with this topic, learn is actually locked with a base of e. Okay, your 5x is the result, and the negative 1 is the power. So you have two things here. So when you adjust them accordingly, so you will get e to the power of negative 1 equals to 5x, e to the power of 1 over 3 equals to 5x as well. So when you run the calculation accordingly, we get x as e to the power of negative 1 divided by 5. That's about e to the power of negative 1, then divided by 5. So it's approximately 1 over 5e. On the other end, your x will actually be e to the power of 1 over 3 over 5, or it can be written as cube root e over 5. So it's up to you. So these two will be your final answer for question 1. Okay. So moving on to question 2, here you were given a graph and they are looking for your A, B and C's value. So the first thing that I would normally do for this type of question is actually to identify the middle line's value. So if you look at it, the center line is somewhere around here. Okay, so this line here actually indicates a very important information, as it tells us how much was the vertical translation. So the vertical translation here will be 4. So the first thing that I identified was C equals to 4. And the next thing that I'm going to do here will be checking the gap from the center to the highest point and the center to the lowest point. The gap is clearly just 3. This 3 here is actually amplitude's value. So your amplitude's value will be the 8 over there. Then we have one last thing to identify here, which is your periods calculation. To get it done, you will have to look at where this cycle ends then. So in default, a sine graph will actually ends at here. Okay, they normally ends at 2 pi. But in our case, okay, they show us 0 to 2 pi, but the value is only half of the original sine graph. So what it tells us is that to complete the entire graph, it will be until 4 pi. It was being stretched out basically. So to get to the results, okay, when we apply the formula, it's actually 2 pi divided by b equals to our current ending point, which is 4 pi here. Okay, so when you run the calculation accordingly, you will get your b's value as 2 pi divided by 4 pi, which is 1 over 2. So that's your b value here. So your A, B, and C is now fully complete. This is your A, this is your C, this is your B. So the formula, the 2 pi over b, there's actually a fixed formula for you to identify the period. And the sequence that would do it is actually to identify the vertical translation, followed by amplitude, then the last thing is to calculate the period. Okay, so you must know that if half of it is only under 2 pi, which means that we will go through another 2 pi to get to the end. So this 4 pi here, you must know how it works in order to secure the marks for this question. Okay, so this is for your question 2 here. Let's go on to question 3. So question 3 now, the line AB is such that the point A and B have a coordinates, okay, where it's -4, 6 and 2, 14 respectively. Point C has a coordinates of 7A, lies on a perpendicular bisector of AB. So the keyword here is your perpendicular bisector, so you're required to identify it first. So let's run our gradient calculation. So gradient calculation here goes by y2 minus y1, which is your 14 minus 6 over 2 minus -4. So through this calculation here, you will get your results as but remember, they're referring to perpendicular bisector. So you need to find your mu here. So the mu that we are dealing with is actually -3 over 4, as well as we need the midpoint for this calculation. So the next thing that I'm gonna do after identifying a perpendicular bisector will be midpoint. So the calculation of it is pretty straightforward. You actually get it as -1 by 10. So with this value here, you can now proceed with your calculation. So let's find our equation here. Y equals to -3 over 4x plus c. Substituting the points, so you actually get c equals to 10 minus 3 over 4, where the results will be 37 over 4. So this is how you get to the full equation that we will be using here. Okay, so to identify your point C, we will need to substitute the 7 and A given to us. So the 7 will be replaced into the X position, and we'll get our A's results as the final answer of it is 4. That's how you secure the marks for 3A. Moving on to question B. Given that point D also lies on the perpendicular of AB, find the coordinates of D such that line AB bisect the line CD. So based on this question, there's two things that they want us to focus on. First thing will be perpendicular bisector, and they mention the bisect again. So when they mention it twice, then very likely the question has something to do with the C that we identified and also the midpoint that we gotten. The midpoint is actually -110. This is our midpoint. And our C is actually 7 and 4. So based on what we have, this is basically the midpoint. So to trace to the answers, maybe I can check the vector, like how many steps would it take for us to get to the midpoint here and then go up. So the vector shows that it was about -8 because you have to shift to the left, and then to go up they will go through a 6. Okay, so from the midpoint here, if I want to get to our point D, okay, from our midpoint I'll be taking -110 plus -86. So the final answer of this will actually be -9 and 16, which is about this as the final answer. Okay, it's actually kind of tricky because the way they phrase the question. So if you notice that they mention the word bisect twice, then very likely they want you to use it as a core information here. So with this, you should be able to continue in solving the question. So moving on, we have question 4 next. Question 4 is actually a completing the square. Okay, first step that I'm going to take is to extract the 2. Okay, so with this, I then focuses on the center only, our 5/2x there. Since they're using plus, means they are referring to the A plus B types of arrangement. So we have A squared plus 2AB plus B squared. So the shaded red part will be what we are comparing here. You should know that the A is actually your x. Your 5/2x equals to 2xb. To get to your b value, it will be 5/4. Okay, so with this 5/4, we can then proceed and rearrange everything here. Okay, I change it back into the format that they wanted. So I have -3/2 here. This is the integer that we didn't touch earlier. And remember, because we added a b squared into the equation all of a sudden, so you're required to minus it back out at the end. So you have a -5/4 square that I place at the end here. So kindly take note on that because it's very important. So to finish up the calculation, I will first not multiply the 2 into the equation. I will try to solve whatever that I have here, which is by taking -3/2 and then I minus the 5/4 first. Okay, you actually get -49/16. So with this -49/16, you can get to your final answer by multiplying the 2 into it, which fulfill the condition that the question set. So you get -49/8 as the end. So the A here will be the 2, your B will be 5/4, and your C will be the -49/8. So that's how you get to the answers here. Okay, moving on to part B, find the coordinates of the stationary point. So this part is actually quite straightforward because you already done the completing the square. So that's nothing to do for you. You're just adjusting the information. Okay, so you got your x equals to -5/4. Then your y's value is actually this at the back. So the so-called turning point or stationary point here will actually be -5/4 and -49/8 as your final answer. Okay. So they asked us to sketch it out. Okay, interesting. So again, I'm gonna do the quadratic first. Okay. If you look closely, you'll notice there's a modulus. I will explain this later. Okay, so try to always solve whatever that you can. Okay, let's key in again, make sure everything is correct. This one is 2. Okay, the next one should be 5. And the last one should be -3. So with this, you can factorize them as x plus 3 as well as 2x minus 1. So that's how you get to know that they intersected at these two points. Okay, so roughly maybe my 1/2 is somewhere around here. My 3, however, could be somewhere around here. Okay, that's the two things that I identified. Then when you look closely, this -3 is very important because they will tell us where did it intersect it. So they mentioned it was -3, so maybe it's somewhere around here. Okay, you can actually use your turning point here because your -5/4 is actually a -1.25, so maybe it's somewhere around here. Okay, this is your -5/4, and our -49/8 is actually 7 point something. So it could be located somewhere around here for the turning point. Okay, so with this, you can now roughly sketch it out. It might look something like this. Okay, notice that I didn't intersect exactly over here. Okay, because they didn't ask for the turning point actually. So it's okay for you to leave it. But make sure that all this point that you use, it must be accurate as possible. So you notice that I readjusted here. Okay, then the one last thing is to fulfill the modulus function. Okay, modulus function means that you cannot accept anything that is underneath in this particular part. Okay, so your task now is to get rid of it. So to get rid of it, you're gonna reflect it upside down. So all this, if you want to keep, but make sure you keep it in the dotted form. So your one last part to finish the calculation is to reflect it out. And make sure you label the 3 here. As the question wanted, intercept with the axis. So those are the coins that they gave you the marks. So make sure those are correct. Okay, so with this, it will be your final format here as your answer. Okay, so this is how you sketch out modulus. You can either get rid of the entire dotted part, okay, or if you want to leave it there, then make sure you change it into dotted line. Okay, so that's pretty much it for part C. And D over here, they mentioned that have exactly 3 distinct points. Okay, so what they're trying to tell you is they want you to know the question is actually referring to this part. The so-called numbers of solution is actually the intersection. Okay, so they actually intersected with the graph in these 3 parts. So these three parts will be the answer, where your y's value is actually the turning point that we gotten earlier. Okay, the y value was negative 49 over 8, okay, based on these results here. But since we reflected it up from negative, it will becomes positive now. So for you to get to the case value, you must write it as 49 over 8. Okay, that's how you secure the one last mark there. The so-called three distinct solution is the numbers of solution, or how many points that they intersected on. Okay, so you need to know roughly where you should draw the line for this particular question. Okay, so this is for your part D here. Moving on to question 5. Okay, this is your relative velocity. Okay, so they mentioned the position vector was 0, 0. In 3 hours time, we have a position vector of 12 and 9. Find the position vector of OP of A at time t. So if this is the case, the solution of this will be, so these 3 hours here play a crucial role. You must know that t equals to 3, and you have something here that you're trying to find. Okay, they mentioned that it started from the point of origin. How do you get to negative 12, 9 then? Okay, so this is the x and this is the y. So x must be something where they multiply together. 3x will be negative 12, while your 3y will be 9. So when you run the respective calculation, you will get your x as negative 4, as well as your y equals to 3. So with this, you're able to construct the position vector OP of A at time t. So the answer should be 0, 0 with negative 4, 3 pairing with a t there. That's how you get to your answers. And for part B, with a constant velocity of negative 5, 8. Alright, so if they just want you to write out the solution, this will be how it looks like. Okay, just like this, you secure your next questions 1 marks there. Okay, so to get to your answers of PQ magnitude, okay, for this, all they want you to do is to know that you are using PO plus OQ first. You must add up the results before you complete your calculation. So to find this, basically you are dealing with 0, 0, okay, plus negative 4, 3, t. But please remember, because there's a change of direction here, there will be an additional negative at the front. So when you add it up, this will be your final results. Okay, finish the calculation first before you run the Pythagoras theorem. Magnitude here basically hints you are using Pythagoras theorems here. So to finish it up, you have 4t at the front plus 12 minus 5t. Okay, and for the numerator, you have negative 3t plus 6 plus 8t. So the ultimate answers that you should be getting will be 12 minus t followed by a 6 plus 5t. So from here, you run your Pythagoras theorem calculation. Okay, then the results would look something like this. Let's verify it. So 12 times 12 should be 144 minus 24t plus t squared, adding up with 36 plus 60t plus 25t squared. So the answer is 26t squared in total. and then plus 36t plus 180. So that's how you get it done for this particular question here. To avoid any confusion, I will rewrite the symbols here. So make sure you don't confuse yourself with t and the plus there. That's how you get to these answers here. In part D, they want you to show that A and B does not collide. So you're gonna run your calculation here. What we have will be our 26t square plus 36t plus 180. You run your b square minus 4ac's calculation. So you actually have 36 square minus 4, 26 and 180. You can now check your results. 17,424, which your b square minus 4ac is actually lesser than 0. If it's lesser than 0, means they does not collide. Okay, so this is very important. Hence, A and B do not collide. Okay, that's how you secure the last 2 marks here. So we are halfway through the paper now. Moving on, we have our calculation of geometric progression. First term is 10, sum to infinity is R6. Okay, so we got our A as 10. S infinity is by taking A 1 minus R, so we actually get it as 6. Okay, so this is your equation 1 and this is your equation 2. So to find the common ratio, I will be adjusting our equation 2 here. From 2, we actually get it as 6 1 minus R. So our A sub A equals to 10 into 3. So 10 equals to 6 minus 6R. 6R is actually 6 minus 10. R will be negative 4 over 6, which is approximately negative 2 over 3. So that's how you secure your ratio here. So part 2, they asked us to find the sum of the first 7 terms and correct answers to 2 decimal places. So let me pull up the formula here. Okay, so for this, it is actually S7 equals to A 1 minus R7 1 minus R. So our A was 10, our R was negative 2 over 3 to the power of 7, 1 minus negative 2 over 3. So when you sub in the calculator and run the calculation accordingly, from here you should get 6.3511659.808. To make it into 2 decimal places, it will be 6.35. That's how you solve part 6, number 2 in A here. So moving on, we have our B with a logarithm. Okay, interesting. So to get it done, they ask us to find the common difference of this progression. So the common difference here will be by taking our D equals to U2 minus U1. Okay, we have log x3 square minus log x3. So it's basically 2 log x3 minus log x3. So you only have 1 log x3 as the balance. So this will be our common difference here, log x3. find in terms of n log x3 and the sum of the progression, sum to n term. So let's trace based on our formula here. We have 1 over 2 with our a, and then n minus 1d. So when we substitute our n accordingly, 2 log x 3 plus n minus 1 our log x3. Okay, so you will get your answers as 1 over 2 n. So I write it as n over 2 to simplify it first. As for the one at the back, we have 2 log x 3 squared. Okay, I will get rid of the 2 at the front. Okay, then we have log x3 n minus log x3. So what this that we have here actually means is that, so from here what I'm gonna do next is to run some calculation here first. Okay, maybe I shouldn't shift the 2 and put it back. So we have log x3 plus log x3 n. So this thing at the back basically tells us that it is n over 2 log x3 1 plus n. So this will be my final answer or final arrangement here. Okay, so you need to play by ears. Okay, adjust your variables accordingly. Okay, there's no one solution fits all here. You have to make your own judgment when you're dealing with the question on the spot. Okay, given that the sum to the x n term is 3081, so we have n 1 plus n over 2 log x3 equals to 3081 log x3. Notice that both sides has log x3, then you can get rid of them, and what you have left will be this. I will be taking 3081 times 2, you get it as 6162. Readjust them, then you can now go on and find your value of n here. So use the same mode. Press the wrong thing. We're using this 1 negative 6162. You have two answers. One is with n plus 79 as well as n minus 78. So among these two, you have to decide which one is the more suitable one. So like I said, n terms can never be negative. So this one is not suitable. The final answer should be 78 only. Okay, that's how you get it done. Hence, given that the sum to n term is also equals to 10, 1027, find the value of x now. Okay. So the sum to the power here is this. We know that it is 1027. Okay. When we adjust this arrangement here, okay, 1 plus n, n plus 1 is the same thing. So if I follow the arrangement that I have, then I should write 1 plus n equals to 1027. So transform this back into indices format. So we have x as the base, 1027 equals to 3 to the power of n, 1 plus n over 2. So from here we should be able to trace the results now. Okay, since we already know what's our n there, right? So when you sub in n, cube root of 1027, n was 3 to the power of 78, 1 plus 78 over 2. So let's key in this accordingly. Put this with 1027. Inside I have 3 to the power of 78, 79 over 2. The answer of this will be 27. So make sure you utilize all the information that you identified to obtain the final answer here. So this is for your part number 4. So we are now doing question 7. So they first asked us for the perimeter of this trapezium here. So immediately there's one thing that you need to know is that since it's a rectangle, the square root 17 plus 1 will be shared over here. So these are the characteristics. So if we look closely, we notice that there's only one thing that we are needed to find here, which is this AE length. Let's utilize our Pythagoras theorem, where you have AE squared equals to ED squared plus AD squared. So if you identify AE's result, please remember to add a square root to get rid of the square there. Then fill in the blanks accordingly. Okay, so like they mentioned, do not use calculator. So try to write as many details as possible for your calculation. Okay, as for the other one, it will be 18 plus 2 square root of 17. So if this is the results, these two will be cancelled and you get your final answers as. So with this, we can now proceed and add everything up. So when you finalize the calculation, you will get your results as this. That's 14 plus 4 square root 17. So this will be your final results of 7A here. Moving on, we have B, where they ask you to find the area of the trapezium. So for our trapezium formulas, you can either split it into a triangle and a rectangle, or you can just use the formula straight up. So over here, I'm going to show you how to use the formula. So our formulas that we are using here should be top plus bottom. Divided by 2 and multiplied with the height here. So you actually get 10 square root 17 plus 58 divided by 2. So when you divide this thing by 2, you will get your answers as 5 square root 17 plus 29. So this will be your final results for the area of the trapezium. Moving on, we have section C, where they're asking for tangent AED. So let's have a look at our sheet here. They wanted tangent AED. It's referring to this. We'll be using its opposite and adjacent to complete the calculation. So we have square root 17 plus 1 at the top divided by square root 17 minus 1. So this will be our tangent AED's results. Okay, but like I said, they cannot accept to have square root at the denominator, so you're required to rationalize this by multiplying a square root 17 plus 1. So through this, you have square root 17 square minus 1 square, while the numerator you will have 17 plus 2 square root 17 plus 1. So 18 plus 2 square root 17, then you have a 17 minus 1 at the bottom. So to fulfill the condition of having 8 as a denominator, I'm required to extract 2 from the numerator part. Then after the simplification, you will get your final answers as this. And your 9 square root 17 over 8 will be your final answer. So we have one last part here that goes by sec squared AED equals to 81 plus 9 square root 17 over 32. If you look at the conversion table at the top, your sec square is actually 1 plus tangent square theta equals to x square theta. So if you utilize this concept, what it basically tells us, it is actually 1 plus tangent square AED. So if this is the answer, then our square will be dealing with this. So when we expand it out, so when you run the calculation accordingly, you have a 64 at the front. This is because it actually have a denominator of 1. So you multiply 64 on both the top and the bottom. And then for the 1 at the back, you will have your result as to make it to become 32, I need to divide everything by 2. So I should have 81 plus 9 square root 17. So these two will be cancelled, and you have the final answers as this. So you should be able to prove these results here then with these steps here. So this is actually from your first page, the conversion table over here. Okay, just in case you're wondering how I get to this result, this is the details, so you can refer to it anytime at the front. 8 part 1. So they want us to prove this, so I'm gonna try to adjust the tangent. Tangent is actually sine x over cos x. So you should be having a sine square x over cos x plus cos x. Okay, remember, they will have a denominator of 1. So to make it the same, for the one at the back, I will multiply it by another cosine. So now you have a balance of this at the numerator. So sine square plus cos square will result in 1 over cos x will be the sec x that we are looking for. Okay, that's how you get to the result. For part 8, number 2, however, the first thing that I notice here is that there's a changes in the theta's value. So I must update the range first. 0 divided by 2 will still be 0, but 4 pi divided by 2, it will be 2 pi. So with this out of the way, we know that we can write this sec theta over 2 equals to 4. But there's no calculation that we can key in on calculator here. So So you must adjust the value now and get to this. Sort them up through cross multiplication. Then to get to the value, please analyze this. Since it is a positive, our cosine will only be positive when they are in the first and the fourth quadrant. So what 0 is here, when they go through all the way around, they arrive at 2i. Okay, so now I'm gonna key in cosine inverse, 1 over 4, and theta over 2. Okay. Make sure your calculator is in radian mode. I'm gonna update this first, and then cosine inverse 1 over 4. Okay, you'll get your answers as 1.318. That's your theta over 2's value. So this 1.318 is actually over here. So to identify the next value, we're going to take this like a reflection line and reflect this to the other side. So this is the first answer. The next one will be by taking 2pi minus 1.318. So to get to your theta's final value, make sure you multiply the other side by 2. So your theta will be 1.318 times 2, as well as 2pi minus 1.318. So 1.318 times 2, it will be 2.636, as well as another one, it will be 9.93. So make it into 3 significant figures. This will be my final answers here. Okay, so that's how you get it done. So let's recap quickly. First step is always to update the range. Okay, that should be your first step. Then after that, you need to utilize whatever that you've gotten from the previous part, and you can check the value here, is it positive or negative. Then I'm gonna sketch this graph out on the side to help me to identify the result. Then final steps will be make sure that you multiply the results by 2 because there's a changes in range there. Okay, so that's pretty much it for 8 number 2. Moving on, we have part B here. So the mention it was a cotangent y plus 38. So the same thing, I'm gonna update the range here first. So instead of starting from 0, it will now start from 38, and the other side will be 398. Okay, so cotangent cannot be solved unless you take it like a tangent here. Adjust it accordingly, and this is what you're having. So this result here is clearly a positive. So let's sketch up the range. Kindly take note that they only accept the result from 38 all the way until it is 398. And for tangent to be positive, they will appear in the first and the third quadrant. If this is the case, then you're gonna proceed and trace the results. Make sure you change your calculator back into degree mode. Okay, how do you identify this is by checking the value given in the range. Okay, so change it back and then key in tangent inverse 1 and then square root 3. y plus 38 equals to tangent inverse 1 square root 3. So the answer here will actually be 30. Okay, but instead of writing it as equal sign, I will now use this curly sign here. Reason being, 38 actually fall underneath the starting point. So somewhere around here only, which means that we might not have a suitable result. 30 is not suitable here. So the first answers that I'm getting should be this, where I transfer this 30 to the other side. So the first result should be 180 plus 30. And to get to your next result, it's actually by turning it all the way around until here. So it's actually 360 plus 30 for the second answers here. So y final value will be 180 plus 30 minus 38. As for the other one, it will be this minus 38. So your final answer is 172 and 352 respectively as the y final value. Moving on, we have question 9 here. Okay, they want us to find the qx value. Alright. So to get to the quadratic factor, you have to run the division process here to get it done. So we have a 2x cubed minus 3x squared minus x and then plus 1. So we have 2x minus 1 here. To get it done, you're required to check. So let's say to get to the first there, I need a x squared, so that I can have a 2x cubed minus x squared. So the balance from this, please remember in polynomials there's always an invisible minus that you don't have to write down, but you must know it's there. Okay, that's why I've written it in pencil. Okay, so the balance from this, remember the negative will be applied to values inside. Okay, so to get your answers, you actually have a negative 2x squared balance minus. So to get to negative 2x, I need to multiply with our negative x again. So I have negative 2x squared now plus x. Okay. So the balance from this, remember there's still an invisible bracket with a minus at the front. So the final answer of this will actually be negative 2x plus 1. So to get it done, I will put a minus 1 at the end. So that's how you get to the qx value, which is a x squared minus x minus 1. Okay, so that's your final answers here. Okay, so write your px in the form of this. It will be 2x minus 1 and then x squared minus x minus 1 as your final answer. In 9 part B, they ask us for the coordinates here where these two lines intersected. So they need these 2 points for you to complete the calculation here. Okay, if you look closely, these two equations is actually equals to this part. When you put them equals to each other, when you finalize it up, you actually get to the equation at the top. So if this is the case, we're gonna use the factors that we already gotten. Okay, they actually intercepted at 2 points here. So let's have a look. The first one would actually be 2x minus 1 equals to 0. X will be 1/2. And the other one is actually from this equation here. So for our remaining coordinates that we are trying to identify here, you can now use your quadratic. So key in 1, -1, -1. you get the points as x equals to negative 0.618, or the other one as x equals to 1.618. Okay, so clearly the more relevant one would actually be. And there's one thing that I missed out here. They mentioned they wanted the exact coordinates. So if the exact coordinates is what they wanted, I cannot write it in this current format. I must update what I have here into square root 5 plus 1 over 2, and the other one is actually negative square root 5 plus 1 over 2. So this should be the answers, and this one is not relevant, okay, because there's no negative here. So if I were to set who as A and who as B, A will clearly be this, and B will clearly be this. Okay, so that's how you get to your final answers here. So they didn't want you to identify the exact shaded area of this current shapes that we have here. So between 0 to 1 over 2, I will be integrating this equation. As for 1 over 2 to square root 5 plus 1 over 2, I'll be integrating between square root 5 plus 1 over 2 and 1 over 2. So to construct the equation, it will look something like this. 1 over 2 to 0. Okay, we have negative 2x square plus 3x plus 1. Adding up with square root 5 plus 1 over 2 to 1 over 2. That will be a 1 over x here. Okay, to get it done, your final answer will be you might find it troublesome to get it done. Okay, I will show you the calculation on the side for the integration part. So we actually do the one at the back first because it's just ln x. Okay, quite straightforward for that. But for the rest, it's slightly tricky. If can, you can split them up if you don't know how to do it. You can set your dy dx equals to negative 2x squared. The y of it will have unknown integers, but the power will decrease by 1. So you actually have x cubed here. So your dy dx of that will be 3 unknown x squared. Compare these two variables accordingly. You have 3 unknown equals to negative 2. Unknown will be negative 2 over 3. So that's how I get to this result. And for the next one, just repeat the same steps. Your dy dx is basically 3x. Your y, the power will increase by 1. There's an unknown at the front. 2 unknown x. Unknown will be 3 over 2. And then you have an x here. Okay, the 1 will be transformed into x. Okay, so that's how you get it done. Substitute the 1 over 2 and 0 into it accordingly. So you will get your final answer of this as 19 over 24 plus learn square root 5 plus 1. I can't write the results in decimal form because you will have unlimited decimals at the back. Okay, it's very troublesome because you can't get to the exact area that they are looking for here. Notice that they use this keyword everywhere, so you must fulfill the requirement that they have set there. So if this is the case, you're gonna key in your -2/3. Then you can verify my calculation here. Okay, that's how I get to the 19/24 there. Okay, so that's it for this question 9C. So we have one last question here, which is our question 10. So our dy dx, to get it done, you need to know that your top part will be the ux, your bottom will be the vx. Your u prime, however, it will be 3/2, 2x squared plus 10. Minus the power by 1, you have 1/2 is the balance, then you have 4x here. So when you readjust them, you will have a final answer of this after the simplification, whereby for your v prime, you have 1. So when you adjust it accordingly and apply the formula, you have a square at the bottom, which is your vx squared. Okay, for here, I will actually take the center value, these two, put them together, you have 6x, 2x squared plus 10 to the power of 1/2, multiply with x minus 1, minuses off with the balance at the back, you have this 2 here. 2x squared plus 10 and then 3/2. To fulfill the question requirement, they want us to extract x minus 1 squared out of it. Same goes to this plus 10 to the power of 1/2. So this thing here, this one, and this is basically adjusted. So the balance inside the bracket will be your 6x and then x minus 1, as well as your 2x squared plus 10. Then it's actually 2/2 at the back. 2/2 is basically 1 there. So to sum up your calculation, this is how it will look like. So that will be your final answer here. They mentioned that this curve, okay, your x must be more than 1 and it has only exactly one stationary point. So for you to find stationary point, you must make sure that your dy dx is equal to 0. So what we have left will be this that we adjusted earlier. So when you shift this to the other side, you get 0 basically. So your 4x squared minus 6x minus 10 equals to 0. When you run your calculation, you have your x value as this. So this one doesn't fulfill the x more than 1's condition. So this one is not acceptable. The x value of your stationary point should be 5/2. And then the other one that we have is actually the 2x squared plus 10 to the power of 1/2 equals to 0. So I first square them both, and then I have 2x squared plus 10 equals to 0. 2x squared equals to -10. X equals to square root of -10/2. So you can actually verify this calculation here. Okay, personally I won't do this at all because the answers here is too small to be considered as more than 1. Okay, notice that there's I over here. Okay, that's to tell us that it is not acceptable as well. Okay, only the denominator, this specific part, will be gone. Then the rest you're required to verify them. So basically you are setting these two equations here equals to 0 to figure out what's your final answer. So that's pretty much it for this particular paper. Not really that hard, but I would say the workings is troublesome. Okay, so all the best for your upcoming examination, and I hope this video here will help you out in your exam preparation. Okay, bye bye.